Let me just close this transcript. Yeah, you go ahead. Wait. Yeah, you can start, Akanksha.
Okay. Hello, everybody. Today we are going to discuss regarding a machine learning project. And my name is Akanksha. We are from Group 7. My team members would include Darshak, Revant, Avinash, Rishita, Shakira, Vikas, and Zangdu. Uh, the principal component analysis, which is called PCA for dimension reduction. It's nothing but it is a technique in machine learning and statistics used for dimensionality reduction. It transforms high dimensional data into a lower dimensional form while retaining as much variance as possible. PCA identifies the directions, which is the principal components in which the data varies the most, and the projects the data into these components. By reducing the number of dimensions, PCA helps in simplifying the data set, making it easier to analyze and visualize, and often improving the performance of machine learning models. Now we are going to discuss regarding the dimension reduction. It's nothing but it's a process of reducing the number of features that includes variable or dimensions in a data set while retaining as much valuable information as possible. It is a critical step in data processing, particularly when dealing with high dimensional data sets. The main goal of dimension reduction is to simplify the data set, making it more manageable for analysis, visualization, and modeling without significantly sacrificing the data integrity. The next part will be explained by one of our teammates. Thank you.
Darshak, you can go ahead and
Hi, I'm going to discuss about hyperparameter tuning using grids. Let's discuss about a definition. Hyperparameter tuning is the process of finding best set of hyperparameters for machine learning algorithm. Hyperparameters are the configuration settings and extend to the model to impacts model performance. Grid search is a technique where the predefined set of hyperparameters is tested, impacts executed to identify combination yield to best model performance. Based on specified evaluation methods about grid search. Grid search is a hyperparametric tuning tool used to find the best set of hyperparameter for machine learning. In this grid search, a predefined set of hyperparameters for a specified algorithm is specified. When Haxier's search is performed, overall possible combinations of the hyperparameters. This model is trained and evaluated for each combination and one of the yielding the best performance. Next, continued by my teammate.
yeah. Hello. I'm gonna tell about assemble learning using Adabot classifier. The definition is like assemble learning is a machine learning technique where multiple models are combined to create a stronger or more accurate model. Adapt boosting, nothing but adaptive boosting, is one such assemble learning method that combines weak learners to create robust classifier. Adapt specified samples, allowing subsequent weak learners to focus on the difficult classifiers, thereby improving the overall model accuracy. When coming to the AdaBoost classifier, what is the AdaBoost classifier? Adaptive boosting is an assembly learning method that combines the multiple weak learners to create a strong, accurate classifier. It works iteratively by assigning the higher weights to the misclassified samples and allowing subsequent weak learners to focus on these difficult instances. Adaptive boosting combines the predictions of these weak learners, giving more weight to the accurate classifiers, resulting an overall robust model. There in this application, we have included bonus session as well. Our application involves scraping data from the JSON file, and we are performing machine learning tasks with the scrapped data here. Specifically, we are loading data from JSON file, that is nursery.json, which we have used earlier in our apps, in our ML apps, into a data frame. We are loading it into data pandas data frame, and then proceed with the data processing, dimensionality reduction, and hyperparameter tuning using grid search and assemble learning using the AdaBoost classifier. These applications fulfill the requirement of using data from a JSON file, making it eligible for the bonus mentioned in the task given in the description. Let me show you the file where we have the JSON. This is a JSON format. This is a JSON file, and I'm including the. Let me just open that. Okay, let it be. That is a JSON file we have taken here. So coming to the code, I already executed. Usually this takes long time to compile each and every cell. So it took me 20 to 30 minutes to run all the models here. So I cannot run again, since it's gonna take a long time. So let's go with the. So I have got the results here from these cells, all the cells and the models which we have implemented. Let's go and explain about this. I'm going to explain everything here. So this is the data set which we have taken earlier. So I'm taking the same data set. So nursery database was derived from the hierarchical decision model originally developed to rank applications for nursery schools. It was used during several years in 1980s, where there was an excessive enrollment to the schools in Ljubljana and Slovenia, and the rejected applications frequently needed an objective explanation. The final decision depended on the three sub-problems: the occupation of parents and child's nursery, family structure, and financial standing, and social and health picture of the family. The model was developed within an expert system shell for decision making DEX. So when coming to the feature description, we have variable role type missing values, parent feature, and has nurse feature. These are the features which we have got in the JSON file, and so these are nothing but a number of columns, and these are the number of rows which is there in our JSON file, like instances. These are the number of rows, and these are the columns. And possible values of categorical columns includes these are the categorical columns which we have got nothing but 8. So you can see the 8 fields here. So coming to the we are loading the data set here. As you can see, I'm importing each and every library which we need for this application. Okay, so I'm importing everything here which we have been studying from our class. So I'm importing the nursery.json here. So data equals to, like this is, we all know about that, like we are loading the JSON file. You can see here JSON file, and we are converting the JSON data into panda data frame here. This is the step. Okay, data equals to pd dot data frame. So coming to the data processing, here we are handling the missing values in this step. In this step, we are handling the missing values. So you can see the following code here for that. And encode categorical features. We are encoding the categorical features over here. So we are encoding each and every categories here. You can see 1, 2, 3, 4, 5. We have got 8 fields here, as we discussed earlier in the data set. And we are splitting the data set into features and the target variables. You can see here we are splitting the data set into features and the target variable. This is the following code. These are the just initial assignments, and we're splitting the data into training and testing sets. As you can see here, we have got train and test variables here, X and Y we have used, and this is the following code for it. And to function the evaluate model, so we are functioning the we are evaluating the models here. As you can see, evaluate model inside this, we are passing all the model X test and Y test. And so this is the following code behind the evaluating the models here. We are evaluating it, and using the dimensionality reduction technique principal component analysis, PCA, to reduce the number of features while preserving most of the to the data HDG with the principal component PCA. Okay, so this is the following code for it. We are importing sklearn dot from PCA, and so I have written the steps here, as you can see, for the following code. Apply PCA for the dimensionality. So this PCA equals to PCA underscore. So this is the following code. And coming to the step 2, training the model with the reduced features. As you can see here, we are training the model here, HDG underscore classifier underscore PCA equals to HDG classifier alpha equals to 0.001. Oh, this is max 8 equals to 1000. So we have taken random values over here to show the kind of reduced feature. Then we are evaluating the model over here. As you can see, these are the model, like these are the HDG accuracy, SDG, SGT, precision, SGD, recall, and everything. So this is what we are going to display here. As you can see, accuracy, precision, recall, and F1. So we have got some values over here. So these are the initial assignments in the above, which we are not printing anything. We are just initializing it, and we are here we are going to print everything. Since we have taken like initialized and we are performing all the models. So as you can see here, we're printing each and everything, accuracy, precision, recall, F1 score. We have got the accuracy, precision, and recall with the HDG classifier. And here we are discussing about HDG classifier with I2 regularization and RFE feature selection. So here, HDG classifier. So this is a following code. Here we are printing HDG classifier. For the HDG classifier, we are getting accuracy, precision, recall, and F1 score. And again, we are taking RF selector here. So RFE. So this is the following code to select top 5 features here. And for example, for the L2 regularization is also here in this code. Okay, we are training and testing the modules, and HDG accuracy, HDG precision, or whatever we are going to print here. We are evaluating everything. As you can see, evaluate model. So we are evaluating it in this code and printing everything. So HDG classifier with RFE feature selection. As you can see, the accuracy, precision, recall, and F1 score over here. For the HDG classifier, the accuracy is this one, and the precision and F1 score. You can see the difference here with RFE feature selection. We have got some difference, and compared to both, we have got some differences for the same outputs. Okay. And we are using a grid search for hypermetering over here. As we discussed earlier in the definitions, we are using a grid search in our models. These are the import we are taking from grid search CV, and we are defining a grid of hyperparameter to search for it. So these are the following variables we are taking, and here I'm in this code. We are creating a grid search object. Okay, and we are fitting the grid search to the data here, train and test, both are train. and we are getting the best hypermeters here. Best underscore params equals to grid search dot best params. Okay, and we are training a new model with the best hypermeters here in this code. We are training a new model with the best hyper parameters. As you can see, hyper underscore classifier underscore. So here the alpha, max, iter, and the penalty. So these are the variables we are taking, and we are evaluating the tuned model also here. So whatever the accuracy, precision, recall, and F1, we are showing here with the hypermeter tuning. So best hypermeter, this is our best hypermeter accuracy and everything. So we have got the output here for the hyperparameter tuning, the best hypermeter. So you can see the alpha has 0.01 and the max iter has 2000 and penalties like L2. Okay, so we have got the accuracy, precision, and recall and F1 score. You can see the output details here. Okay, and uh, I'm using an assemble, and then coming to the last and final one. I'm importing sklearn dot assemble import from AdaBoost classifier library, and creating this step is we are creating a AdaBoost classifier. As you can see, AdaBoost classifier equals to AdaBoost classifier and everything. It's same like the previous step. I'm adding alpha, max iter, 1000, penalty equals to L2, and we are giving these two as well, and we are training the AdaBoost classifier in the following step. Okay, so in this one we are evaluating the AdaBoost classifier model, and finally we are printing all the AdaBoost classifier here. You can see. So coming to the SVM classifier with principal component PCA. Okay, I forgot about this one. So this is not the previous one is not the launch. We have still more. So PCA, principal component analysis for dimensionality reduction. Here we are taking the same as like before. We are importing from sklearn decomposition. And in the step one, as you can see, we are applying a PCA for dimensionality reduction. This is the following code for it. Extend PCA, fit, transform, and transform. And in the step two, we are training the model with the reduced features. Okay. This is the following step for it, and evaluate the model. We are evaluating the model here in this step. It's same like the similar, it's all similar like the earlier codes, and we are printing SDG classifier with PCA. Okay, so here we are getting accuracy, precision, recall, and F1 score. As you can see here, this is SDG classifier with PCA. Okay, and here we are using again using grid search to hyperparameter tuning for SVM. Okay, using grid search for hyperparameter using for SVM. We are using SVM. Okay, so here in this the same like we are importing grid search from sk.model.selection and defining a grid of hyperparameter for SVC, and no, I think it's SVM. Okay, param underscore grid C kernel gamma. We are taking the different values over here, and we are creating a grid search CV object. So grid search, we are initializing it and creating the grid search object, and to fit the grid search to the data, this is the following code, and getting the best hyperparameters. This is the following code. Best underscore SVC equals to whatever. Okay, and train a new SVC model with the best parameters is SVC underscore classifiers underscore tuned. Okay, so this is the following code for it, and we here in this code we are evaluating the tuned SVC model. I think it's SVM. I should call it as SVM. accidentally I wrote it as SVC. That's fine. Tuned SVM classifier. Best hyperparameter is 0, 1, and 1 and poly, and accuracy, precision, and recall, and F1 score. Okay. So these are the following output we have got here, and using assemble AdaBoost classifier for SVM. Okay. So this is the following code for it from sklearn.svm import SVC. So we are taking SVC, and from sklearn assemble import AdaBoost classifier. So create an SVC classifier. So I have taken SVC here. Okay. Equals to SVC. So this is for creating SVC classifier. This is for creating AdaBoost classifier with the SVC as a base estimator. And this is the following code for it. And training the AdaBoost classifier, the following code is this one. And evaluating the AdaBoost classifier, Ada accuracy underscore, comma, Ada precision, Ada recall, and whatever the accuracy, precision, recall, which we have got from the earlier session. So AdaBoost for SVC is accuracy, precision, recall, F1. F1 score is this one. And when coming to the fire with RFECV, okay. This one we are discussing about SVM classifier with RFEVC. So coming here, we have got like we are importing RFECV from sklearn underscore dot feature underscore selection. So here, this is the following code for it, and same like we are training the models and evaluating it. All these steps are here. And finally, I'm printing the SVM classifier with a SVC feature selection. All this code or here, and we are printing here F1, F accuracy, precision, recall, and F1 score. You can see SVM classifier. We have got like accuracy, precision, recall, F1 score. All these are the ones. And SVM classifier with the RCB features is this one. As you can see, difference over here. And coming to the KNN classifier with the sequential feature selector, I'm using the following code for the same like before, like initializing and evaluating the model, and finally printing the output for accuracy, precision, recall, and F1 score. Okay. So here we have got the output for KNN classifier, and also KNN classifier with sequential feature selector. Here you can see I'm using sequential feature selector with the KNN, K nearest neighbor. Okay. Following code for it, and I'm evaluating the model, initializing it, and printing all the outputs here. We have got two outputs, as you can see here, and this is a hyperparameter tuning, assemble, dimensionality reduction for decision tree. So we are taking all the necessary library imports from sklearn, okay, and creating a decision tree here in this step. Decision tree, adjust the maximum depth as needed, as we have taken 3, that's fine. And step 1, in the step 1 we are applying a PCF for dimensionality reduction, as you can see here. This is the following step for it. And step 2, for this one, train the decision tree model with the reticulation feature. Okay. And for the step 3, we are evaluating the decision tree model over here. Okay. And finally, we are printing it. Accuracy, precision, recall, and F1 score. And we are creating an AdaBooster classifier with the decision tree as a base estimator. So this is the following step, and train the AdaBoost classifier. So this is the following code for the following, like evaluating the decision classifier with the decision tree, and I'm finally printing it, and accuracy, precision, recall, and F1 score. Okay. Define a grid of hyperparameter for the decision tree. we are defining a grid of hyperparametry here. As you can see, maximum depth, minimum sample split, and minimum sample leaf. So this is the following code. And here we are creating a grid search object for a decision tree. This is the following code. And we are finding the grid search to the data. So X underscore train PCA and Y underscore train. Okay. Get the best hyperparameter for the decision tree here. We are getting the best hyperparameter which we have seen earlier, and train a new decision tree model with the best hyperparameters. So this is the following code for it. To train a new decision tree model with the best hyperparameter, as you can see up to here, and evaluating the tuned decision tree model. So this is the following code for it, and I'm printing it finally. Okay, so we have got lots of like outputs over here, printfs, as you can see. Okay, we have got 3. So decision tree with the PCA, this is the output you got. So as you can closely observe here, you have got like differences with the values. AdaBoost for the decision tree with the PCA. Then you have got this output, accuracy, precision, recall, F1 score. And the final one, tuned decision tree with the PCA. We have got this one, best hyperparameter, and we have applied everything with like decision tree with PCA and AdaBoost for the decision tree with PCA and tuned decision tree with the PCA. So this is the final output. We have got like 13 cells over here in our application, and we are showing each and every output, and we have used everything like whatever our assignment says. Dimensional reduction, hyperparameter tuning. We have discussed all about this one. Okay, and the data set which we have used is the earlier data set, since we have to use the earlier data set in this application to show the differences between the previous and the new application over here. And about our application, and we are from group 7 from Zipping Glue professor class, machine learning class. Thank you everyone.
Thanks, Ravan.
You can stop the recording. Anyone can stop the recording, please.